Next is frequency density. So frequency density is the frequency per unit of a class interval is the frequency density. That is F divided by C, or it is the ratio of class frequency to the width of that class interval. Okay, the frequency density formula is frequency of the class divided by width of the class. So F is your frequency of the class and C is the width of your class here. Okay. Let us look at an example here. The given class intervals and the frequencies. First we take the class widths here. So the width is, for the first class it is 10. For the second class it is 30 minus 10, 20. For the third class it is 50 minus 30, 20. It is 60 minus 50, 10 and 65 minus 65. So these are the respective class widths. Now the formula for frequency density is class frequency divided by class width. So 10 divided by 10 would be 1. 15 divided by 20 would be 0.75. 40 divided by 20 would be 2. 45 divided by 10 would be 4.5. 20 divided by 5 would be 4. So these are your frequency densities. Okay, so frequency density are used to compare the concentration of frequencies of different classes for a given frequency distribution. Okay, so by this number you can understand which class interval has a higher concentration here. For example, this class interval, okay, the frequency is higher than anyone else. Its density is 4.5. So the maximum concentration of the frequency of a distribution are at the class 50 to 60. This is how we can use frequency density. Okay, next, relative frequency. It is the ratio of the frequency of the value of the variable to that of the total frequency. Okay. So relative frequency is equal to frequency of the value of the variable divided by total frequency. That is frequency of the variable divided by the total frequency. For example, here given is number of heads frequencies. So 2, 0 and 1. This is the example of 2 coins, tossing 2 coins. So you may get either 2 heads or 1 head or no heads. So 1, 2 and 1. The total is 4. So you are dividing each of these frequency by 4. So 1 by 4 is 0.25. 2 by 4 is 0.50. 1 by 4 is 0.25. The total answer is 1. Okay, so this is your relative frequency. Okay, next. Principles of classification. There are no strict rules for classification. However, the following general guidelines may be considered while classifying the data. Okay, so there are no hard and fast rules of classification of data. But only thing is, if you follow these steps, it would be simpler and better. So let us look at the steps one by one. The first one is the number of classes should be generally between 4 and 15. So the class intervals here, for example, these class intervals, the number of such class intervals here, they are 6. In some problems they were 4. Okay. So the intention of constructing a frequency distribution is that you are compressing or you are condensing a huge data into form of a smaller table so that anyone can understand the data by looking at the table or get the details of what is there in the data by looking at the table. Okay, so if there are a huge number of class intervals, okay, on an average your normal long notebook, there are almost 23 to 25 lines. If it is a big book, then there will be across 30 lines. Okay, so if the entire page is filled with the data, at first it actually looks odd, and second one, it makes difficult for a common man to understand that table. Okay, the intention of classifying is to reduce the data to a smaller form, but if the form itself is big, then it becomes more complicated. Then what is the, then there is no use of putting the table. So hence the number of intervals should be as possible as above 4 and below 15. If you classify the entire data in one interval, then it is as good as not writing the table itself. There is no use of doing that. Okay, you are writing the intervals because you are classifying the data. you are categorizing the data into further sub-ranges. Okay, that's why it is called sub-range. The class is called sub-range here. Okay, you are classifying it to further sub-ranges, and if you write the data into entire one range, then there is no use of writing a table. Hence, a frequency distribution should not contain more than less than 4 and more than 15 class intervals. Second one, exclusive classes should be usually kept constant throughout the distribution or may be different for the proper meaning of subject matter of the data. As far as possible, if you can choose exclusive classes, they should be, the width of the classes should be uniform. So even if there are difference in the width of the classes, it should justify according to the necessity of the data. Okay, for example, age group of human beings 0 to 18, you are not an adult, you are considered as a juvenile or a kid or children. So after 18 till the age of 40 or something, you are considered as a young person. From 40 to 60, you are considered as a middle aged, and from 60 to 80 or 60 and above, that is an open class interval, it is considered as old age. So here there is a no uniformity among the class intervals. 0 to 18, the width is 18. 18 to 40, the width is 22. Okay, 40 to 60, the width is 20. 60 and above, there is no width at all. Okay, but writing the class intervals in that form actually justifies the data. Okay, hence exclusive class intervals should be written, and as far as possible they should be kept constant throughout the distribution. Next, the width of the class should be usually kept throughout the distribution, or may, the point is repeated, avoid open-end classes because the mid values of such class cannot be easily computed. As far as possible, we should avoid the open-end classes because we are not getting the width of the class, and with the width we also are not getting the midpoint of such class for the calculation purpose. The classes should be arranged in ascending or descending order. So it should start from lower value to higher value, or higher value to lower value. It should not be haphazard. The lower limit of the first class should be multiple of 5. So as far as possible, the class intervals should be divided in the form of multiples of 5s or 10s. Usually a width of 5 or 10 is considered as better, because we as a human beings, there is a common psychology that we remember things in the form of a set. We easily remember the table of tens or 5 because there is a exact calculation, half and full. 5 we consider as half and 10 we consider it as full. So if you construct the class intervals with a width of 5 or 10, it would be easy for you to remember the class intervals or write the class intervals. Or while classifying the data, when you are classifying the data points with respect to their class intervals, it would be easy for you to identify the points and write them under the specific class intervals they belong to. Okay, so these are some of the points that you need to remember while constructing the continuous frequency distribution, while classifying the data. They are not hard and fast rule that you should do this, but if you do it, it will be for the betterment of the distribution.